Oh, by the way, very quickly about the videos. On Thursday, I decided to try to, all those long pauses where I ask you to figure something out, and then you work on a problem for like 10 minutes. Well, it turns out on the video, those are really boring because I write the problem up and then nothing happens for 10 minutes. And so I was playing around with clipping those out. And I also discovered that if I stand here and rattle this cup, it's really, really loud on the video because the microphone's right there. So I'm going to keep these over here and away from the microphone a little bit more, and I'm going to rattle them less. Brett, how do I move this equation up or down? Brett's not here. Why not?
He's in New England.
Really?
Yeah.
Sweet.
Yeah.
Avery, how do I move this thing up or down?
Y, I did y equals x minus
X minus what?
4.
Okay, what if I wanted to move it up?
Y equals x plus 4.
And what if I just wanted to move it up or down, not by 4, but by some amount k?
Y equals x minus k.
Minus k?
Plus k.
Plus k? Wow, that seems awfully familiar, doesn't it? Okay. How about maybe I can fool you on this one? Left or right? How do I move this equation left or right? Oh, by the way, I'm going to draw a little copy. I'm going to do the +4 one right here since that's the example that Avery gave us. There's y equals x plus 4. Here's y equals x. How about left or right? Tristan, how am I going to move this left or right?
I mean, isn't
Nothing? If I wanted this to be right here, what could I do to that equation, y equals x?
wouldn't you just put the and then so this x plus k?
Does that work? I feel like x plus 3 would be over here because intercept of 3. So what would this one be?
-3.
Yeah. What if I just wanted to move it by h, Tristan? Instead of 3.
Would it be x plus h? Or minus h?
Which?
Minus.
It's a bit weird, isn't it? Because that looks exactly like that, except with a minus h instead of a plus k. But why isn't that just up or down? Well, sort of is, isn't it? Would it be fair to make the argument that even though I moved that up 4, I could also look at it as, oh, I moved it to the left by 4? because it's the same graph whether I move it left by 4 or up by 4. Still goes through all the exact same points. Fair enough? How about this one? Stretch or compress? Karen.
I said y equals 2x.
Good. Is that a stretch or a compress? Oh. So it just goes up faster. Yeah. What if I wanted it to go up slower? Ooh, would that be going up slower?
Or half.
Yeah. Yeah, what would that do? Yeah. So that sort of looks like slope to me. Stretch compress when we're dealing with a linear function just means change the slope. Taryn, how about if I just wanted to stretch or compress it by A?
Y equals a.
Put it all together. Here we go. Colors. Nope, I've got black. All together now. Y equals A parentheses x minus h plus k. Wow, that looks super familiar, doesn't it? Now, here's where the difference. Sorry, allergies. I've got a tickle in my throat right now for some reason. Guys, here's where the difference between up, down, and left, right comes into play. Left, right goes into parentheses, which means it's affected by the stretch factor. Up, down is out of the parentheses and therefore not affected by the stretch factor. But let's look what happens to point H, comma, K on our graph. I am going to graph y equals, and I'm going to leave a as 1, just to not confuse the issue, x minus 2 plus 3. What's h comma k? Anyone? Shout it out. Yeah? Yeah?
I was going to say not -2.
Agreed? Not -2 because x minus h. So how do I transform y equals x to get to y equals x minus 2 plus 3? Well, I go 2 to the right and up 3, agreed? So this point right here becomes 2 comma 3. Yes? Well, what if I said y equals x minus 3 plus 4? Is that the same line? I take this point and I go 1, 2, 3, 1, 2, 3. Huh, you made it, look at that. Same line. Well, if I simplify x minus 2 plus 3, that's the same as x plus 1, right? And x minus 3 plus 4 is the same as x plus 1, right? What if I gave you y equals x minus 4 plus 5? Same line? Yeah. What if I gave you y equals x plus 2 minus what if I gave you x plus 2? Same line? No, not the same line. What did I do wrong here? What did I do? Is it my drawing or my math in my head? Wait, it's my drawing. How did I get x? What did I do? How did I? Oh, wait. What did I do? Help me out here. 2, 3. 1, 2, 1, 2, 3. 3, 4. I think it's my drawing. I think my scale is off. Yeah. No. What? Let's ignore this one because it's I don't know what I just did there. What did I just do? Because it should be y equals x plus 2 minus 1, agreed? Which would be over 2 down 1, which means that I should be over here, and I don't know why I'm not. So I'm assuming that the scale's off because I don't have grid. I don't have grid paper. Agreed? There's something weird. I did something weird there.
You should take a permanent marker and make a grid on your whiteboard.
What?
You should take a permanent marker and make a grid on your whiteboard.
Yeah, never gonna happen. Yeah, okay. There's something wrong with my graph because I don't have the grid. So it is what it is. But here's the thing that I noticed. Do we agree that this is a point on the graph? But so is this, and so is this. And if I had graphed this right, so is that. It turns out that h comma k is just defined as any point on the graph. Because if I'm going to transform something by 2 comma 3, then 2 comma 3 becomes a point on the graph. And if I want to transform something by 3 comma 4, then 3 comma 4 or 3 and 4, then 3 comma 4 becomes a point on the graph. Because regardless of where I am, I started at 0, 0. Which means that if I transform the graph y equals x by h and k, then h comma k becomes a point on my graph. Does that make sense to you guys? I start at 0, 0, and I go h, and I go k. Guess what? There's a point on the graph. And I could just as easily have said, hey, look, here's another point on the graph, and I'll write the exact same equation. But we also know that this is the slope. It's the steepness of my graph. Normally 1, y equals x. 2, the Taryn gave us, a half, negative 2. That's the slope of my graph. So what I can do then is I can take this and very, very easily say that the transformed version y equals m instead of a x minus, and this is h, and this is k. But if h comma k is any point on the graph, I'm going to call it x1 comma y1. Some point on the graph. Doesn't really matter. Instead of hk, I'm going to say x1, y1. But that makes this equation look like this. Now, why do I care? It's linear. It's so darn easy. Let's say I said that I have a line and it has a slope of 2 and goes through 2 comma 1. Well, 2 comma 1 is a point on the line. That's x1 and that's y1. And the slope is 2. That's m. The equation of this line is y equals 2 times x minus 2 plus 1. Done. What would I have done in the old days? I would have said, well, this is the olden days. When I by olden days, I mean like right up until just this second. I would have said y equals 2x plus b. And then I would have plugged 1 and 2 in there, and I would have said 1 is equal to 2 times 2 plus b. And so 1 is equal to 4 plus b, which means that b is equal to negative 3, and therefore y is equal to 2x minus 3. Are those the same? Yeah. Look at that. 2x minus 4 plus 1. 2x minus 3. And how long did it take me to write that equation?
Second.
Approximately a second, maybe even a second and a half, because I was talking while I did it. How long did it take me to calculate this one?
3 seconds.
Yeah, at least a minute. Maybe 40 seconds, because I'm really, really good. Guys, this is called the point slope form of a line. And it is the general transformation, y equals a x minus h plus k, except we write it just a little bit differently because we recognize that a is the slope and hk is just some point on the line. Which means that if you're given the point on a line and a slope, you can write the equation of that line in about 2 seconds. All right, ready? Speed drills. Point, slope. I'm going to write a point and I'm going to write a slope. You tell me the equation of the line. Here we go. 5 comma 6, 1/2. Throw your hand up if you know the answer. 5 comma 6 with a slope of 1/2. Willem.
1/2 parentheses x minus 5 close parentheses plus 6.
How many people think that's the equation of that line? If you put up your hand, you're wrong. It's not even an equation. How do I make that an equation, Willem? Y equals. Thank you. All right, ready? Negative 2 comma 4 with a slope of 3.5. Go. What's the equation of that line? Put your hand up if you think you got it. Roberto.
Y equals 3.5 parentheses x plus 2 close parentheses plus 4.
Oh my gosh, that is about probably the easiest thing you've done since the first grade, isn't it? You got 1 apple and you got 1 apple. How many apples do you have? 2, Mrs. Smith. Boom. This is almost easier. Guys, we cool with this? That's topic number 1, transforming linear functions. We are now done transforming linear functions. do you need to take these equations and rewrite them in y equals mx plus b form? No. No. Now, the only thing you might need to know is that sometimes you're going to see this written slightly differently. Sometimes you're going to see it written like this. Y minus y1 equals mx minus x1. They clump the y's together, they clump the x together. Doesn't really matter. It's the same thing. But this is sort of interesting because we're going to be talking about something a little bit later today. And if I think about it a bit differently, you know the big long discussion we had about y at minus 8 but plus k? Oh, look, it's minus h and minus k. So one way to think about that is that the reason it's plus k is because we put the k on the side away from the y so that we have a y equals we can type into our calculator or the Desmos and we can play with it. We can do stuff with it. It's easier to do stuff with. If you put it with the y, oh look, they're both minus. And we're going to be looking at that a little bit later today in some of the non-functions that we're going to be working with. You don't have to worry about this one, but you should recognize both of those. If you have a highlighter, that'd be a good time to highlight. Anyone need to borrow a highlighter? This movie Madagascar, the monkeys. If you got any poo, that'd be a good time to fling it. You remember that? Those are the ones where they escaped from the zoo, wasn't it?
I think that's the first one.
Was it the first one?
I don't know.
When they're escaping from the zoo to try to go back to.
No, I think it's the second one.
I just think that.
When they go to Africa?
Well, they're from. I think they were from. Like
They're going back to Africa.
they're going back to. Like one of them was from Africa, and then they decided to escape from the zoo. You guys haven't. Not everybody's seen Madagascar.
I don't mess with animals.
Oh my gosh, it's such good movies.
I don't remember.
They are
that
so
one.
good.
Yeah, but you mess with me and I'm here.
Yeah, but they did. They had the one like because the monkeys. That's what they do. It's like they throw. They actually do that in real life. Is that if their tribe is threatened, they'll like get up in the trees and they'll throw poo at you because most animals don't want to have poo thrown at them, so then they leave. So at one point, the chief of the monkey tribe says, "If you got any poo, that'd be a good time to fling it." It is
I just
so.
like the little weird squirrel thing who's obsessed with King Julian.
Yeah. Yeah, if you haven't seen Madagascar, you should. They're good.
Wait, isn't that the one with I like to move it.
Yes, yes.
Oh.
All right. Let's talk about a non-function. Oops, I didn't have to erase the word transforming. Darn it. Now I have to do more work. Hate it when that happens. I have to write the word transforming again. Transforming. Non-functions. Guys, we're going to look at two non-functions. We're going to look at the first one together, and then depending on how much time we have, we will either look at the second one during T3, or I might have to send you with a little bit of the second one home to finish it up. But the process is going to be very similar, so be real careful about watching the process. Instead of y equals, we're going to write this as x equals. Now, you might be thinking to yourself, yeah, but Mr. Harmony, I could just write this as y equals. I'm going to suggest right now, I'm going to ask you not to. And here's what I'm going to ask you to do instead. I want you to write a table with as many XY pairs as you can possibly think of that make this true. Try to stick with whole numbers, no calculators. What numbers can you think of off the top of your head that you could stick in there and would make this true? All right? So I'm going to give you a couple minutes to think about that. Populate this with as many sets of numbers as you can. Pairs of numbers that make that true. Go. If you think you're done, find more. Melissa, can you give me one pair of numbers that makes that true?
2 and 4.
Are you telling us that 2
Oh,
is
no,
equal to 4 squared?
No, I don't know. I'm confused.
Well, very simple. 2 is not equal to 4 squared. But what is true?
And 4 is equal to 2 squared?
Aha, 4 is equal to 2 squared. Avery, can you give us another pair of numbers?
9 is equal to 3 squared.
9 is equal to 3 squared. Elijah, can you give us another pair of numbers?
16 is equal to 4 squared.
Put your space on here.
25 is equal to 5 squared.
Yeah, but you know what? Tristan, darn it. I hate that. Willem.
36.
Now I'm getting bored. Give me different ones. Don't go any bigger. What are we missing off of that?
25 is equal to negative 5 squared.
Oh, 25 is equal to negative 5 squared. Darren?
16 is equal to negative 4.
Oh, 16 is equal to negative 4 squared. Roberto?
9 negative 3.
9 is equal to negative 3 squared. Oscar?
4 and negative.
Emery, what are we missing?
I don't know.
Fraction.
Oh, yeah.
Don't care about fractions. But you're right. But we're just looking for whole numbers. Yeah, what? There's a really obvious one that's completely missing.
0.
Oh, 0 and what?
0.
0 is equal to 0 squared. So let's graph this. Here we go. 0, 0. Uh-oh. No, we're good. I'm only gonna go to 9, because then the graph gets too big. Uh, 4, 2. Oh, I see another bunch of ones that we missed. What else did we miss?
1, 1.
1 and 1, yeah. So I'm gonna move 0, 0 up, and I'm gonna put 1, 1, and 1, -1, because this is gonna give us a really nice graph. I love it, it's so beautiful. This is called a sleeping parabola. And think about it. We switch the numbers. Y equals x squared would be 1 squared is 1, 2 squared is 4, 3 squared is 9, and we'd have a parabola. And instead, we got x equals y squared, and we've got a sleeping parabola. So here's what I want you to do now. I want you to take this equation, and I want you to solve for y. And I want you to put it into your graphing calculator, and I want you to get that graph in your graphing calculator. Go ahead and solve for y and put that in your graphing calculator. And when you have a graph that looks exactly like that in your graphing calculator, put your hand up and I'll come around and look at it. I will ask that you not use Desmos. If you don't have a graphing calculator, you can use the graphing calculator on your Chromebook, but don't use Desmos. Here's the problem. Desmos will actually allow you to type this in, but I don't want you to type this, and I want you to solve for y, and I want you to type that in. And the reason will become obvious here in just a second. So when you have that exact graph in your calculator, go ahead and put your hand up, and I'll come around and take a look at it. Give you a minute or so here to get that graph in your calculator. You got your hand up? Let me see. Oh, interesting. Look at that. What's with the weird grid? Feel like it should be cheated. Yeah, no, I'm not buying it. So here's my question. How come nobody has their hand up yet? Melissa, what did you get when you solved that for y?
I don't know how to.
Wait, what?
Um,
Solve that for y?
I'm just confused.
Solve for y. Write it as y equals.
Y equals what?
Good question. What does y equal? If x equals y squared, what does y equal?
The square root of x.
So what happens when you put y equals square root of x into your calculator? Emery,
You get half of it.
you get half of it. Y equals square root of x gives you that. How do we get the other half? Anybody got an idea as how I could get the other half in my calculator? What's the difference between that half and the other half?
Negative, positive.
Oh, one of them's negative? So what equation could I type into my calculator to get the negative part? Anybody?
You subtract it.
Well, I don't know what you mean by subtracted.
You subtract the positive one. Like you put like negative x squared and like you subtract x squared. Or square root, my bad.
So what are you typing into your calculator?
I'm not sure. Probably like negative square root of x minus square root of x.
Well, wouldn't that just be minus 2 times the square root of x?
Yeah, you can't put positive in either because they just cancel out.
True, true. Roberta, what were you going to say? You had your hand
I
up.
was just gonna say y equals plus or minus square root of x.
Is there a plus or minus key in your calculator?
Okay.
What happens if we put that into our calculator?
Get the bottom.
You get the bottom half, don't you? Here's the thing about graphing calculators. They're not designed to graph non-functions. And this is a non-function, isn't it? 2 values of x for all those, 2 values of y, 2 outputs for every input, for everything to the right of 0, everything greater than 0. So this is not a function, but what I can do is I can say, well, the bottom half of the function is the negative square root of x, and I can say that the top half of the function is the positive square root of x. Make sure you use the negative and not the minus. Negative and minus are different, related, but different. And your calculator will not know the difference. If you try to put in minus root x, it will give you an error because it will say, well, I got nothing to subtract it from. You have to use the minus button. Anytime you want to graph a non-function in your graphing calculator, you got to split it up. Any questions so far? All right, let's do this. Can I erase point slope for me? You all got it? Everybody's happy? I guess those are 2 completely different questions. Y equals plus or minus the square root of x. We're going to combine that into 1 for our purposes. And here's the question. How do I make that go up or down? How do I make that go left or right? And how do I stretch or compress it? Let's just talk about them all at one time. Can you give me one equation that would make this go up or down, left and right, stretch or compress? Anybody want to take a stab at that? Omri?
Y equals plus or minus a square root of x minus h plus k.
Did I tell you guys about my little tail on my square root? This is something my math teacher taught me when I was in high school. If I write a square root and I just make it go like that, is the 2 being square rooted?
Maybe.
Well, it would appear not to be right now, agreed. But what if I made the square root go to here? Is the 2 being square rooted? I think we're definitely at a maybe at that point. But what if I go to here? Is the 2 being square rooted? Maybe. But the further I go, the more likely it is that the 2 is being square rooted. And what this did for me is that it made it I had to think very carefully about what exactly is being square rooted, because when I get to the end, I stop. And that little tail tells me I am now going to stop, as opposed to no matter how fast I'm writing, I never get sloppy because I stop at the end of the square root. And so I found that to be super, super helpful over the years. Because I tend to be a little bit sloppy in my writing. Guys, everybody comfortable with this? This is exactly what we've been doing. Minus h, left or right, plus k, up or down, multiplied by a, stretch, compress. There's no difference. So here's what we want to do now, because here's the problem. This is y equals, and our original problem was not y equals, it was x equals. I want this to be written as x equals. I need to solve for x. What do you think the first step is in solving for x? What would you do first? Pretend they were all numbers. What would you do first? Sometimes. Could I get rid of the square root first, but how do I get rid of the square root when there's all that other stuff around it? Wouldn't it be better to get rid of all the other stuff and then get rid of the square root almost last? So what do I get rid of first? Okay. The k. Let's subtract k from both sides. Y minus k equals plus or minus a times the square root of x minus h. Now what? What would you get rid of next? Anybody? Okay. How am I going to get rid of that? Yeah, let's divide by a. Because I'm going to leave the plus or minus here. It doesn't really matter. But I'm going to leave the plus or minus there for now. Because on the next step, something interesting and fun is going to happen. How do I get rid of the square root? Square. What happens when I square a positive or a negative? What do I get?
Positive.
I always get a positive. When I square both sides, the plus or minus goes away. Just like when I square rooted both sides, I had to put the plus or minus in there. Well, now that I'm squaring both sides, the plus or minus goes back away again. So what I now get is I get y minus k squared divided by a squared equals x minus h. And I wrote that differently intentionally because it's going to give us something interesting here in just a second. Guys, what's the last step?
Add h to the other side.
Add h to both sides, and I get x equals. I'm going to write this as 1 over a squared times y minus k squared plus h. Now, like I something a little bit tricky here. And that's that A. Why did it become 1 over A squared, and what's the difference? Well, the difference is the direction of stretch. If I take y equals and I stretch it vertically, but then I take x equals, what direction do you think that stretch is? It's horizontal. It's a little bit different. It twists up the letters. But here's the thing, it doesn't matter. 1 over A squared is just a number, right? So I can just put some stretch factor in there. And that A and this A aren't the same number, because they're in different directions. But it's still a stretch factor. But notice what we got here, minus K plus H. Notice they're switched. Now that X is a function of Y, X is equal to some function of Y. Remember I told you the other day about Y equals a function of X was a notation that meant that Y was some equation and X was the input. Well, now what have we got? We got X equals a function of Y, but everything's just backwards. We got minus K instead of minus H like we did over here. This is Y equals a function of X. But when I switch it around and make it X equals a function of Y, I've got minus K. My horizontal shift is in there with the, my vertical shift is in there with the Y. My horizontal shift is out here. So we have to just in our head just say, oh, look, when I switch the X and the Y around, all the different stuff switches around. Now, am I going to give you this? Maybe. Good thing to know. I mean, this is the general form of the sleeping parabola. Why don't y'all pull out your Chromebooks and pull up Desmos. And let's type in that equation. And it should ask us if we want to make sliders of A, K, and H. And the correct answer is?
Yes.
No.
But of course. I haven't actually done this, so I hope it works. I got my fingers crossed here. That would be really cool. Remember, you're typing in X equals instead of Y equals. And I hope that it says, oh, this is so easy. I'm totally set up for this. Oh, yes. Woo! Love it when a plan comes together. They say you should never do anything in a classroom that you haven't already tried. Every once in a while, uh-oh, that looks like a linear function. Oh, I feel like you're missing a bunch of stuff. Where's your A? Yeah, but that's because you haven't typed in the equation yet. So back up. Put your cursor at the end of that and hit the back key. Keep going. Okay, now X equals. Dude, why don't you choose keyboard? Way easier. A, parentheses, Y minus K, power of, which is right over the 6. Squared, yep. And then right arrow, you get away from the power, there you go, down plus 8. And now, delta make the sliders. So look at that, that's a parabola. Cool. I'd say if you make, oh, look at your scale.
Yeah.
Oh, okay. I was like, wow, that's weird. Ah, nice, I like it. Everybody Everybody got that sleeping parabola? Everybody got the sliders? Everybody dragging them around? What happens when you drag K back and forth? Still goes up or down, doesn't it? What happens when you drag H back and forth? Oh, look at that, still goes left or right. Woo! Super cool, huh? What happens when you make A negative? Which way?
Across the X of the Y.
Go across the y-axis. So if you make A equal to a negative, you get this. Is that a true statement? Guys, there's a good example of the fact that when I said we've got this 1 over a squared, but this is a different a, we're now reflecting across the y-axis. What happens when you make a bigger? Does it get steeper this way, or does it get steeper this way? Does it get vertically steeper or horizontally steeper when you make a bigger? Anybody? A gets bigger. This way or that way?
It's small.
So I don't know what you mean by smaller though.
Impressive.
So this is A greater than 1? Everybody look up here for a second. Do we all agree that this is A greater than 1? Yeah? So if I make A 5, I get a long, skinny sleeping parabola. Okay? So here's the thing. With this equation, this is no longer a vertical stretch. It is a horizontal stretch. And that is something that you need to add to your notes there. A is now a horizontal stretch when you're dealing with x equals a function of y instead of y equals a function of x. Y equals a function of x, A is a vertical stretch. X equals a function of y, A is a horizontal stretch. All right? One more thing you should probably jot down. To enter a non-function, in your calculator, you must enter each part separately. Y equals plus square root of x and y equals the negative square root of x. For your calculator, you have to put those in separately. In Desmos, you can type in x equals square or y squared. But we're not always going to have Desmos. A graphing calculator is a lot handier to have with us. You know, you think about civilization collapses, the wireless network is down, the internet's gone, you still got your graphing calculator. Your bug out bag has extra batteries for your calculator, right? Of course it does, because who'd want to live without a graphing calculator? All right. Guys, any questions about this? Before I start erasing? Let's look at another non-function. Again, without a calculator. I want you to figure out as many possible values of x and y that make the following equation true. This is non-function number 2. X squared plus y squared equals 25. As many possible combinations of x and y that make that equation true. Just remember, no technology. Don't type this one into your Chromebook or Desmos or your calculator. I really want you to just think about this one. What numbers could you plug into that equation? A value of x and a value of y that would add up to 25. Nice. I saw the pattern there. What else? What other numbers work? I'll give you about another minute. Nice. What else? What you can do with the numbers that you have written down already. You change that would also work. Where are your numbers? I feel like that makes it 26. More? I mean, you've got a nice pattern going there, but what else? What other two numbers can you square? Oh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The challenge is to have 12 sets of numbers on your list. 12 sets of numbers. Ooh. Get close. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So pick a number. Square. What's left over? So if you put in 4,
16.
and then what's left over? Which means that y would have to be.
Oh, so
There's a pair. All right, here we go. Going around the room backwards this time. We'll start at Oscar. Go, give me a pair of numbers.
0, 5.
0 and 5. Amory, give me one pair of numbers.
4 and 3.
4 and 3. Roberto, give me a pair of numbers.
3 and 4.
3 and 4. Oh, look at that, because they're squaring both of them. So it doesn't really matter. Taryn, give me a pair of numbers. -3 and -4. I like it. Tristan, give me a pair of numbers.
5 and 0.
5 and 0. Willem, give me a pair of numbers.
-4 and -3.
-4 and -3. Malaysia, give me a pair of numbers. -5 and 0. Avery, give me a pair of numbers.
I don't remember.
Well, I see another one that's like completely obvious. On the left side. What?
1 and 5?
Ooh, 1 and 5 would be 26, right? I can skip you. Come back to you later.
Okay, yeah.
Melissa, give me another pair of numbers.
I don't know.
Somebody give me another pair of numbers. Anybody?
-4, 3.
-4 and +3. Ooh, that opens up a whole new world of possibilities. Somebody give me more.
0 and -5.
0 and -5. Somebody give me more.
-3, 4.
-3, +4. Somebody give me more. Come on, we can do it. I mean, we got the pattern, right? We only need one of the numbers to be positive and one can be negative. So what else we got?
3 -4.
3 -4. What else?
4
4 -3. I think that might be it. Yeah, 12. Let's graph them. Go. Beautiful, lovely graph. Not in your calculator. On your graph paper. If you don't have graph paper, that'd probably be a super good time to go grab a piece of graph paper because we want this to be beautiful. Of course, that doesn't apply to me. Why? Why would you put like little randomly spaced checks when you've got beautiful graph paper here? Here you go, start over. Beautiful graph paper, go by ones. Graph paper right over there in the tray behind Karen. Grab a piece of graph paper. Grab Malaysia a piece of graph paper also, please. Dude. Graph paper. We want it to be beautiful. So, that's 3, 3. Only because I know what it's supposed to look like when we're done, and so I was like, man, that one doesn't look like the right place. So much nicer. So, now that you have a whole bunch of dots, if you were to connect the dots, what shape do you think you might get? I'm gonna go ahead and I'm gonna sketch a curve through my graph. And I'm gonna say that it sort of is gonna look like that. And it's gonna look like this. You see why I wanted you guys to have graph paper? Because mine's a little bit off because I had to sort of wing it here. And it's gonna look like this. And it's gonna look like what do you think? What shape do you think this is? Where's the center of the circle?
Here.
What's the radius of the circle? We cool with that? So, here's what I want you to do now. X squared plus y squared equals 25. I want you to solve for y and put this into your graphing calculator. Do not put it in Desmos at this point. Or if you do, be very specific that you put into Desmos what you get when you solve for y. So I want that in y equals form. Think about what you need to do. Remember, you're going to want to do this on paper before you go typing it into a grapher. Wait, what? If you square root x squared, why do you get square root of x? Oh. Yeah, what does that line look like? I just sort of gave you a hint in the function. What does that look like? So what does that tell you about your equation, y equals 5 minus x?
Not right.
True statement, because can't be a circle and a line at the same time, agreed? So go ahead and do the algebra on paper before you take it in. If you want to work your way through step by step, starting with x squared plus y squared equals 25, what are the steps to solve for y? And then and only then do we take it into our calculator and say, aha, there it is. That. Okay, now what? Now y equals y squared equals. What do you gotta do? What does that look like? You get there into exactly. So what does that tell you about that equation and this equation? Which means you can make mistakes somewhere in the process. where did it become, where did it go from being a circle to being a line? What step? So what does that tell you about the step that we used to get from here to here? Yeah. So your step was probably fine, but your simplification was not. Yeah. Press zoom decimal. You'll see hopefully something interesting. Yeah. It chops off the edges, that's too bad. But notice that it makes it a nicer, nicer shape. Interesting. So what went wrong? It was a circle and then you simplified it and now it's a line?
It was a curved line.
Would it be fair to say that if we simplify circles, they become lines?
No.
So what does that tell you about your algebra?
I messed it up.
Which step? What was the step that made it turn into a line?
Oh, the Y square.
Right here, right? So what does that tell you about the square root of that and 5 minus x? Are they the same thing? See the problem? Try typing in the previous one. So now we can do. You down? Okay. Now what? What does the graph of 5 minus x look like? So what does that tell you about going from here to here? Yeah. Is it right to take the square root of both sides? Really? Because you want to get rid of y squared, right? So the only way to get rid of y squared is to take the square root. But doesn't that just tell you that your simplification is wrong? All right, guys, let's take a look at this because I'm seeing a lot of people doing the same thing. Y squared equals 25 minus x squared. Take the square root of both sides. Square root of y squared equals square root of 25 minus x squared. Square root of y squared is y. And there's a lot of people writing 5 minus x. What does the graph of that look like?
Line.
What does the graph of this look like?
Half circle.
I'm just going to say circle, but sure, half circle. So where's the mistake?
Oh, you just keep it like the square root on top?
The square root of this is not 5 minus x, and we just proved it. Because if it was, they should look exactly the same on a graph. You can't take the square root of each individual thing inside. Let's look at an example. What is the square root of 16 plus 9? Agree or disagree? Well, why isn't this 4 plus 3, which is 7? I mean, square root of 16 is 4, square root of 9 is 3, so that should be 7, right? Am I lying? Am I wrong? Because that is exactly what you did if you start here and you go to there. You're taking the square root of each individual thing instead of taking the square root of whatever's underneath the square root symbol. Can we all see that those are two completely different things? And that this one, by the way, is wrong? Imagine that a square root symbol acts like a parentheses. So you have to do the thing inside before you take the square root, which means that when we get to here, we got to stop right there. As Amrit said just a second ago, we got to stop there. The square root of 25 minus x squared is equal to the square root of 25 minus x squared, and it is not equal to 5 minus x. You guys all cool with that? Okay. So, go ahead and type y equals square root of 25 minus x squared into your calculators. And Emery already said that's a half circle. Where do I get the other half circle?
The negative.
Got to put another one that says y equals the negative square root of 25 minus x squared. Now, it's going to look like an oval, not a circle in your calculator. The reason it's going to look like an oval is because look at the shape of your screen on your calculator. It's a rectangle. It's stretched in the horizontal direction. So anything that's a circle will actually look oval in your calculator because of the way the screen is built. All right, you guys ready for the fun part? Wait, you mean that wasn't the fun part, Mr. Everding? I am starting with y equals plus or minus the square root of 25 minus x squared. And I want to shift it vertically, shift it horizontally. We're not going to worry about stretch for now. I want to shift it horizontally and shift it vertically. What do I do with that equation? We make it move up or down or left and right. Think about that for a second. What could I do to that equation to make it go up or down and left or right? And then test it in your calculator. You can even test it in Desmos if you wanted to put in H's and K's. But not x squared plus y squared equals 25. Y equals plus or minus the square root of 25 minus x squared. Left, right, up, down. Willem, any ideas on making it go up or down?
Up or down,
Yeah.
the square root of 25 minus x squared outside of that plus k, right?
And do we agree with that? Does it make sense that if I just take my whole table of values and add some number to them, that all of them will move up by that amount or down by that amount, just like on every other function that we've done? How about the left, right? I think we all know it's going to be minus h. Hopefully we all know that at this point. But the question is, where does the minus h go? Oscar, where do you think you might stick the minus h? Take a guess. Take a wild guess if you're not sure. Here, I'll get you started. Y equals, go. Where would you put the minus h in that equation?
By the y.
Where did it go on every other one? y equals x squared, y equals x cubed, y equals square root x, y equals absolute x, y equals 1 over x.
Near that.
Oh, near the x. So plus or minus square root of 25 minus, tell me when, x minus h squared. Hey guys, here's the question I have for you. What's different? Nothing. Y equals x squared, y equals x minus h squared. Y equals x cubed, y equals x minus h cubed. Y equals square root of x, y equals square root of x minus h. Y equals absolute x, y equals absolute of x minus h. Y equals 1 over x, y equals 1 over x minus h. Y equals square root of 25 minus x squared. Y equals square root of 25 minus x minus h squared. Oscar said when at the perfect time. Because nothing has changed in every single function we've transformed. We went to the x, and we said, hey, let's write an x minus h instead of an x. Boom, there it is. We put an x minus h in, which means that my equation is now with both transformations, y equals plus or minus the square root of 25 minus x minus h squared plus k. Type that into Desmos. You do a plus or minus in Desmos or two?
I think you can.
Which might make this easier, because then maybe we can have one equation in Desmos, whereas our graphic calculator, we need two equations. Is there a plus or minus? Try typing PM, see what happens. No. There may not be a plus or minus. Let's leave this for now. Let's not type it into Desmos for now. Everybody stop. We jumped the gun here a little bit. Let's instead do this. I want to get it back to looking like our original equation, which looked like this. Which means I need the x's and y's on the same side, and I need that square root to be gone. What's my first step going to be? Anybody take a wild stab at my first step? There's no wrong answer. I mean, there's things we won't do if you say it, but it's okay to just like take a wild guess. What would you do first? Roberto?
If you squared both sides.
Oh, hang on, we're over here.
Oh.
Sorry,
Oh.
sorry, yep. It's not here anymore because I combined them. This was two different, and now I got one equation. I like the idea of eventually squaring both sides, so what do I need to do first?
It was the X.
Ooh, I can't really get
I
rid
mean, not the X, the K.
of the K. How do I get rid of the K, Roberto?
I'll subtract it.
Sweet. Y minus K equals plus or minus the square root of 25 minus x minus h squared. Now what?
Now squaring.
Now seems like it would be a really good time to square both sides and get rid of that square root, wouldn't it? So on the left-hand side, when I square this, I'm just going to write y minus k squared. I'm not going to simplify that anymore. I'm just going to leave it there, y minus k squared. I know that if I wanted to, I could write it all out. It would be y squared minus 2ky plus k squared, but I don't want to. I want to leave it as y minus k squared. On the right side, what happens to the plus or minus when I square this? Positive squared, negative squared.
Cancel.
They're both positive, yeah. So when I square the right-hand side, the plus or minus goes away, and the square gets rid of the square root. Now what? I want the x's and y's on the same side. What am I going to do? Anybody? X's and y's on the same side. Right now I got y's on one side, x's on the other. What can I do? Willem?
Minus parentheses x minus h.
Minus?
Or add parentheses x minus h squared.
Guys, is it okay to just add that whole thing? Sure, why not? It's subtracted from one side, and I can just add it to both sides. So now I'm adding x minus h squared to both sides, which means that this side is just those two things added together. And the other side, since I added that, it's gone away. So I feel like this looks like the exact same circle, except with an H and a K. What do you think H comma K tells me about that circle? And now would be a perfect time to type that equation into Desmos. X minus h squared plus y minus k squared equals 25. Make the sliders, drag it back and forth. Figure out what h and k does to your circle. Yeah. You need to go to water. Yeah. Okay. Uh-oh, forgot a plus. I've got to multiply there. You're going to have a pretty easy function.
What is that?
Well, we don't know. We didn't get that far. Woo! What happens when you move H and K around? So what does the point H comma K tell you about your circle?
The center.
Oh, look at that. It tells you where the center of the circle is, because our original circle started at 0, 0. But if I move the whole thing by H left or right and K up or down, it changes the center. Ask that question about that. So here's my next question for you. Why didn't we include a stretch factor back here? Why didn't I put an A in front? And the answer to that question has to do with what A represents. What kind of stretch is A if I put an A into this equation? If I write y equals plus or minus A times, what kind of stretch is that? Was that?
Vector compressed.
Yeah, but what direction?
Oh, horizontal.
No. The exact opposite. Vertical. Remember, if I put a stretch factor, I'm stretching it this way, right? The bigger my number, the taller my parabola. The bigger my number, the taller my cubic. The bigger my number, the taller my absolute value function. What do you think happens if I take the equation for a circle and I put a stretch in it?
I just typed it in.
I'm not quite sure what you mean.
I don't know how to explain it.
Okay, so, well, let me ask the question again. What if I were to stretch this by 2? What happens to it?
Is it not a circle anymore?
Why not?
Cause it's like, cause it's not, I forgot the word, where it's like,
What happens to these points? You're definitely on the right track. What happens to these points if I multiply them by 2?
Nothing.
Nothing. What happens to all my other points? If I put a stretch factor into this equation, I would have turned it into an oval instead of a circle because it's a vertical stretch. So where's the stretch factor in this equation? What's the radius of this circle?
5.
What's the radius of this circle?
5.
How do I change the radius? Do this. Everybody go ahead and in your Desmos, change that to 36. And tell me what the radius of that circle is. How much bigger?
9.
Oh, really? Have you done it?
Yeah.
Have you looked at your graph? What's the radius? Easy way to check is going to be to make h and k equal to 0 and then look at where it goes to. What's the radius?
6.
When it was 25, the radius was 5. Why don't you make this equal to 16 and tell me what the radius is?
4.
Anyone want to speculate about the relationship between this equation and the radius? Willem?
The radius squared is the number.
Our equation is x minus h squared plus y minus k squared equals the radius squared. Why don't you type that into Desmos? See if it'll let you make R into a slider. Or what happens when you drag R back and forth? Big or smaller, doesn't it? So the circle is sort of an interesting one because you can't just multiply by a stretch factor. We have to just change part of the equation. It's built into the radius is built into the equation because of the idea of vertical stretch versus horizontal stretch. Whereas to keep it a circle, we have to have a stretch that goes equally in every direction. You cool with that? So, could you give me the equation of a circle that has center at -5, and a radius of 7? Write the equation of that circle. Right there. Go. Center's at -5, 4. The radius is 7. Write the equation of the circle. Malaysia?
I got x minus 5 squared equals y, or parentheses, yeah. Plus y plus 4 squared equals 7.
Couple little things wrong with that. First off, what number needs to go over here? Instead of 7, there you go. And 7 squared is, boom. What's wrong with these two parentheses? Little thing.
The first one should be positive 5, and the other one should be negative 4.
Notice that these are both minus and minus. So we have to do the opposite of whatever these ones are. All right? Guys, we got through the whole classwork assignment, so I'm going to give everybody points, which means you got nothing to take home today. How about them apples? There will be 2 homework assignments up for tomorrow and Thursday. There will also be something simple and easy for Friday. I'm going to try to find just an interesting video related to some of this stuff. So it'll just be watch the video, and I'm not going to give you a homework assignment on Friday. I'm just going to give you something fun to do. I mean, fun to me. But. All right, guys, have an awesome day. Don't forget to message me or email me if you got questions.
Thank you.
Hey, you betcha.
Thank you.
Hey, you bet. Have a great day.
Did you get my assignments turned, that I turned them in? I get really confused, that's why I have like a bunch missing on the due dates, but then I actually like, when you click the assignment, it makes more sense.
Yeah. So here's the deal on the due dates. The problem is, and this is just an adjustment for all of us, the problem is that I'm assigning you guys and Beaker the same thing.
Yeah.
But if for you it's due tomorrow, for them it's due Monday. And
Yeah,
if I was putting 2 separate assignments, then it's even more confusing. And so in the directions, I just wrote, this is when it's due. And just do them anyway. I mean, if you missed one because you didn't see the deadline because it was confusing, just do it, turn it in.
Yeah,
I'll grade
okay,
it.
that's
I'm
what I
not- I'm
did.
not- Yeah, I'm not gonna freak out over due dates because it's so messed up. And-
okay, I was
But,
checking.
you know, don't leave everything to the end, but I know you wouldn't anyway. so.
Yeah. Cause I was like turning it in, I was like, whoa, it's not a day, but it's really good 3 days ago.
Yeah, yeah.
Thank you.
All right, hey, you bet. Have a good day.
No, there's no